Good morning, class. I hope everybody's having a good week so far. I was just going to post a video on some of the properties of exponents worksheets that you guys are working on. I was going to go through the second assignment, obviously not all of them because this video would be super long, but just a few of them. And I'm also going to outline some of the actual properties. I'm going to write those down for you. All right, guys, so last thing before I get started here, make sure you guys are all participating in Google Classroom, whether that's asking a question, sending me an email. Obviously, I would love it if you guys could send these completed assignments to me this week by Wednesday. A good portion of you guys already did, and it's awesome to see that. I post something at 8 o'clock on Monday and I'm having students email me at 9 o'clock on Monday with the entire week's worth of work done. So if you're one of those students that want to just knock it out on Monday, please do so. Every single week I'm going to post all of the assignments except for the assessment on Monday. The answer keys to those assignments will be submitted to you guys after your deadline to turn them in. Excuse me. And then your assignment will most likely be posted on Friday, and it will be due no later than Sunday. So trying to kind of just give you guys a little timeline. I know you're probably hearing a lot of different things from other teachers, so I'm just trying to outline that. So I will be grading every assignment that I give you. It'll be most likely out of 5 points each. And then your assessments will be out of 20 points. And what I'm going to do is take usually 3 of those grades, 2 assignments and 1 assessment. I'll lump them all together in 1 grade, and that goes in the actual grade book as an assessment. And that doesn't start happening until next Monday. So like I said, this week is a trial week. The only thing that is going to happen if you don't do anything is I have to email your name to an administrator, and they're going to reach out to you just to make sure everything is okay, that you have a computer, that you have internet access. So please, like I said, communicate with me somehow this week. A lot of you guys have already done a great job of doing that. All right, guys, so we're just going to outline some of these properties. You probably honestly learned this already in Algebra 1. I definitely taught it to my Algebra 1 students, so I know that you guys should know what this is. This is properties of exponents, but obviously some of you guys took Algebra 1 in 8th grade, so it's been a while. A couple of main properties here, and then we'll start going through some of these examples that have you need to know multiple properties to answer it correctly. So first property is if we have the same base, so I'm just making these problems up. So I have x squared times x to the 5th power. That is the same thing as x to the 7th power. So if you have the same base and you're multiplying, you just simply add the exponents. So the way we got this was x squared plus x to the 5th power. That's where I'm getting that x to the 7th power. And if I wanted to show this out mathematically, what this means is x squared is just 2x's. So I'm just going to lump those together. And then x to the 5th power is 5x's. So 1, 2, 3, 4, 5. And if I count all of my x's, I have 7x's. So that's why that works out like that. So same base, and you're multiplying, you just simply add the exponents. That is my first property. All right, second property, we are going to talk about division. So that first one was multiplication. Now I have my division problem. So let's use the same terms, x to the 5th power divided by x squared. If you have the same base and you are dividing, all you have to do is subtract the exponents. And you always want to take the numerator exponent and subtract the denominator exponent. So this gives me x cubed. If I wanted to show that out mathematically of why that works, we all know that x to the 5th power is 5x's. X squared is 2x's. And as you guys know, you can cross out things that are the same in the numerator and denominator, which leaves you with 3x's, hence x cubed. All right, so multiplication, add the exponents. Division, subtract the exponents. All right, next property is if we have a power raised to a power. And then there's actually a lot of distributing examples in this process on this worksheet. So if I had let's throw a number in here as well. Let's just say 3x cubed, that whole thing squared. All right, so if I have a power raised to a power, I want to distribute this exponent to every single component that is in the parentheses. So what this is going to turn out to be is 3 squared, and I have x cubed squared. All right, so when you're cubing a squared, you're in a sense multiplying them. So this turns into, we know 3 squared is 9, and this just turns in x to the 6th power. So if you have a power raised to a power, you are multiplying that. Let's kind of forget about the 3 right now, and let's explain mathematically why that works. So if I have x cubed squared, that just means I have 2 of these. So I have x cubed twice, right? 3 x's 2 times, which means I have 6 x's. So power to a power, that shortcut is just to multiply those exponents together. All right, the last property that I'm thinking of right now, there might be more that we'll uncover here, is if you ever have a negative exponent. So you can never leave an answer with a negative exponent, right? You always have to have your final answers with positive exponents. So if you have a negative exponent, let's just say it's x to the power of -3. The way that we make it positive is we drop it down into the denominator. This just turns into 1 over x cubed. So the moral of the story here is if you see a negative in your denominator, move it up to the numerator and it becomes positive. If you see a negative in the numerator, move it down to the denominator and then it becomes positive. So a little bit more difficult of an example. If I had like a squared b to the power of -3 all over c to the power of -4, the a squared is positive, so I don't move that. It's just going to stay right up there in the numerator. The b is negative, so I have to move it down to the denominator. And the c is also negative, so I have to move it up to the numerator. You only move negative exponents. If a coefficient is negative, as in a number before the variable, it just stays there. So for example, if this was a -3a squared, the -3 just stays in the numerator. You only move things that have negative exponents. Okay, so we're going to go through a couple of these examples that were on practice 2 worksheet. If you guys have any specific examples, my email was like down yesterday. I tried to email a few of you. I know a couple of you guys had specific questions, but it wouldn't let me email you. So make sure you guys look at my e-learning schedule. I have a Google Voice number that is attached there, and you can text that number or you can call that number and it will actually go to my cell phone. So I will make a separate post about that. But let's go through a couple of these examples. This is the second worksheet. So we'll start kind of nice and slow here. We'll start with number 1. I have 2 quantities here. I have a -7u squared times a 5u squared. I always like to address my coefficients first. So I'm going to do -7 times 5, which gives me a -35. And then I have the same base, and I'm multiplying. So all I have to do is add my exponents. 2 plus 8 is 10. That's it. Multiply the coefficients, treat them separately, and then deal with the base u's. And then since I'm multiplying, I added my exponents. Next problem, very, very similar. -7 times a -6 is a positive of 42. All right, then I have v cubed and v to the power of -9. If I add those two numbers together, I get v to the power of a -6. I know I cannot leave my answer like this because my exponent is negative. In order to make it positive, I just drop that entire term into the denominator and I get 42 over v to the 6th power. All right, 42 over v to the 6th power. We'll do number 3 and then I'll skip down to some of the more difficult ones. Remember, you're only doing numbers 1 through 19. 1 through 18, I believe. 1 through 18. Okay, question number 3. Address the coefficients first. 2 times 3 is 6. And then now I have 2 variables. I just want to look at all of the x's individually, then all of the y's. So I have x to the power of 4 and x to the power of -1. I'm multiplying, so I'm going to add. 4 plus a -1 is 3. And then I have a -7 plus 5. Sorry, my printer got a little sketchy right there. -7 plus 5, which is a -2. Almost done. Not fully done because I have a negative exponent. Everything stays in the numerator except the term that has the negative exponent. So 6x cubed over y squared. Okay, let's skip down to question number 9. Question number 9. The only difference between 9 and 3 is that this second quantity has a power on the outside. So we always want to address that first. So I'm going to take this 3 and I'm going to distribute it to every single term that is inside that second set. So my first set doesn't change. I have 6x to the 8th power y to the power of -9. That quantity stays the same. Since I have a power to a power, I know I'm multiplying, so -2 times 3 gives me a -6. -3 times 3 gives me a -9. Now this question is identical to question number 3. I just go through and treat it. So 6 times my coefficient here is just a 1, just gives me a 6. I have x to the 8th power and x to the -6th power. It's multiplying, so 8 plus -6 is +2. And then I have a -9 plus a -9, which is a -18. So unfortunately, still not done. Negative exponent, have to drop it down. So final answer, 6x squared stays up top. Y to the 18th power gets dropped down to the denominator. All right, let's go through and let's do a division problem here. The numbers 1 through 12 are all multiplication problems. So mainly you're just doing power to a power and multiplying, or you're multiplying with the same base and you're adding the exponent. So pretty much just 2 things there. Let's go down and look at let's do 15. So 15, I have a power to a power. So I want to first distribute this to every term. Don't forget to distribute it to the coefficient. So I get 2 to the 5th power, which is 32, right? 2 times 2 times 2 times 2 times 2 is 32. Pretty sure that's correct. And then I have r cubed to the 5th power, so power to a power, multiply, r to the 15th power. And then I have s to the -15th power, right? And that is all over 4r squared, s to the -10th. So guys, make sure you're either doing your work on a separate sheet of paper or something like that. And make sure when you email me it, don't just email me the answers, also email me your scratch work as well. In order to get full points, you will have to show your work. Okay, so a couple of things that we have to do here is I'm going to first look at my coefficients. I always want to have like one coefficient left in my answer, unless that obviously is a fraction. Like if I got 1/2, obviously there's 2 coefficients there. But 32 divided by 4 is 8, so that just goes up in the numerator. And then now I have the same base, but I'm dividing. So I need to subtract these exponents. So I have 15 minus 2. The answer always gets thrown up in the numerator, and then I address the negative exponents at the end. All right, and then I have a -15 minus a -10. -15 minus a -10. Right? Division is subtracting, right? So don't forget, I always like to write it out so I don't make a silly mistake, but I have this double negative right here, which turns into a positive. -15 plus 10 is a -5, so I have s to the -5th power. Last thing I want to do is I want to make sure my answers all have positive exponents, so I have to drop this term down. 8r to the 13th power stays in the numerator, s to the power of 5 gets put in the denominator, and then I'm done. All right, guys, I'm going to go ahead and post this video. Please email me, do something if you have any questions, and I need full responses from everybody by Wednesday. All right, guys, have a great day. Bye.